Good afternoon, everyone. Thank you for joining my talk today. And thank you also for the organizing team to making this possible. So first of all, I want to give you a short introduction to myself. My name is Tolga Ünlü. I am from the Abertay University in Scotland and currently in my first year of study. In my PhD research, I investigate how to make web applications attack aware and specifically focus on the methodologies and techniques to integrate attack awareness into applications. In today's agenda, I will begin with the problem statement that I'm tackling with my research, and then give a brief description of what attack-aware applications are. In the slide after that, I will give an overview of the two main classes of integration methods that are available, and then give a brief discussion on the key aspect which I am currently following in my research. So if we look at how we are building applications today, and especially in regards of modern practices such as DevOps, then there tends to be more this data-driven decision-making based on the metrics that we collect from our applications, such as performance data or the way in which the users are interacting with the application, so usage data to improve the user experience. But it turns out there is a lack of monitoring or applying the same kind of monitoring for security-related events ongoing within the application. So this is probably because the tendency is still more towards the preventive measures in getting rid of all security issues, but it is also equally important to have some detection and response capabilities in place within the application. And not having those capabilities can lead to some of the following consequences. One of them being that attackers are also aware of this situation and make use of it, because there is nothing blocking them from probing the target as they wish. And by having this time to learn about the ways in which the application can misbehave, this can then eventually lead to the discovery of exploitable vulnerabilities. For the developer or the development team, it would be interesting to see whether the security controls which are already in place in the application, whether they are effective, or whether the focus was too much on a certain part of the application, whereas another part might be more subject to attacks. And same can be said about the threat model, because if we ask our development team and our managers, we get different answers to the question what they think are valuable assets. Same could be said about the attackers. And when it comes to an incident, then you as a developer ideally want to fix the issue as quickly as possible and not spend time on finding the root cause or the issue itself. And also from a much broader perspective, you want to understand how the attacker was able to find this security issue. And I think one approach which can bring this idea of detection and response closer towards or into the applications is that of attack awareness, in which the idea is to have detectors or detection points that are strategically placed inside the application. So we are not speaking of the application layer on the network level, but inside the application code. And the idea is that those detectors are looking for specific indicators of attacker activity. Ideally, these should be very distinctive indicators so that you only get high fidelity alerts once these detection points are triggered. And you can also have like partial indicators, but then you would need to collect a few of those in order to decide based on a threshold or another rule how you want to respond. And response is the second key aspect of this concept, where your application is not just sitting there when it is attacked, but also responding. And this can have different forms. So you can basically just simply terminate the attacker's user session, or also customize the response more. So you can, for example, protect the sensitive areas of your application by allowing only a certain set of users to access those. So the bottom line here is to have applications that can react towards attacker activity and mitigate any activity that continues to target them. And coming back to these detectors, so the place in which they are put and the surrounding application context determines a lot of what a benign user is allowed to do. So as I said, I focus more on web applications. If we take that as an example, you have, for example, validations that are on the client side and also on the backend or the server side. And you, for example, know that a certain client-side validation prevents a user from submitting any invalid values. But if you're able to catch invalid values anyway, then you can be sure at this moment that someone is using, for example, an interception proxy. And these kind of observations you can make by looking for so-called security invariants. And so what you would do here is not only enforcing those invariants that they are not being violated, but also monitoring them when a violation attempt is ongoing and then respond appropriately. So this is the main idea how you can utilize application context to achieve intrusion detection inside the application. And as I have said, was currently more focusing on the ways in which you can integrate those into the application. As also said in the problem statement, because many applications lack this security awareness inside the application. So my first goal was to look at existing methods or approaches to see what their shortcomings or limitations are. And it turned out there are two main classes in which we can separate those approaches in. So the first one is basically where the developers or the development team are manually implementing those detectors inside the application. So it is simply using those code triggers or exception handlers that look for specific exceptions, for example, and then also the implementing the response logic manually. So to some degree, you can reduce this implementation effort by using programming styles like aspect-oriented programming. The idea is that you summarize the detection logic in its own unit, which is referred to as an aspect. And then you as a developer would basically specify at which part of the application you want to run this aspect on and at which execution time you want to run it on. So you can say, for example, a detector is supposed to only run before a certain method is executed or after that. And this is happening at runtime. So for this approach, you ideally should have like access to the source code, and most likely you will then also be part of the development team. So having access to the source code and being part of the team means that you have some expertise, and some of the research suggests that these people having the knowledge of the application or how it works are also the ideal candidates to put the detectors at those locations where most likely a suspicious behavior or malicious behavior can be catched. And this is especially true for business logic-like attacks, because this is tied to your expertise or what your application does. To some degree, you can also utilize common practices like input validation, which has some intersections with detecting probing behavior, and therefore you are not need much more security expertise here, as there are some similarities to practices like input validation. And at this level, having access to the source code and basically being in control of what format you want to use for your detectors or security controls, you can make use of the preferences of your team. So if it turns out that you are making use of a framework where controls are heavily annotation based, then that would be the best way to go then. And or if you want to specify them in a JSON format, that's also up to you and the preferences of your team. But it's still a manual approach, and because of the custom nature of some of the business logic of the application, there's only limited automation possible. For certain attacks, especially like injection attacks, you would not only know how to pull this attack, but also for the implementation of the detectors, you would have to have some expertise to make effective detectors, because you also don't want to spend too much time on the implementation of the detectors or even to maintain them at a later point. So this is why, I don't know if where another approach can be used. So basically you would make use of a software agent, and this is doing most of what has been done manually in the previous approach on behalf of the developer. So all the detection, the injection of detection logic and the instrumentation logic is inside the agent. And this can be used for different types of applications. So if you're targeting an interpreted application, then you can make the software agent part of the interpreter itself. So you would basically implement it in the source code of the interpreter, or if it is supported, load it as an interpreter extension at runtime. Same goes, so you can also make use of this for compiled application, where basically the agent is then loaded as a library at runtime, or which I have seen recently, where the agent is part of the compiler or the compilation process, and while your application gets compiled, the detection logic becomes part of your application's binary code. So for the most usable solutions I have seen, there is this plug and play like deployment mode available. So you would only need just ideally no configuration, but some of them do require at least a little bit of configuration. They also provide like out-of-the-box detection techniques, which are also, of course, limited, which I will explain later. So if we look at which kind of attack classes these out-of-the-box like detection techniques focus on, turns out most of them are, especially when they want to do it in an automated way, of targeting injection attacks, as injection attacks are based on the input that is flowing through the data sources and sinks of the platform. So there is no knowledge of the application code or the business logic required, because all you need to do is instrument those sources and sinks and run your detection technique on the input that flows through these points. And because we don't need to know about the application, how the application code works, we don't have to modify it. So there are some agents that provide interfaces where you can include security controls or detectors for your business logic, but this tends not to be the focus of such agents. So for the detection techniques, especially those that are provided out of the box, they are, as you probably have guessed, signature-based most of the time, so or pattern-based. So they look for patterns of known attack behaviors, or also similar to a signature-based approach, and this has the same limitations as other signature-based intrusion detection systems. Then there are also learning-based approaches, which, for example, try to learn the execution flow when a benign user is interacting with the application. And the idea is that the intrusion is detected based on whether the current interaction leads to a derivation from this valid execution flow. But this kind of detection also applies only to those attacks that lead to derivation of the execution flow. So an input-based attack is, for example, not detected by this kind of detection approach. By design, the agent-based solution can be very platform and technology specific. So you create here additional dependency, because if you want to upgrade your platform, you want also that the agent supports the latest platform, because you don't want to be waiting for the agent until they provide the latest support. Also, if you are, for example, in an on-premise environment, where you are not in control what kind of interpreter you can use or extensions, you might not be able to use this kind of solution. And as it turns out, one solution that I have looked at is also communicating with cloud backend in the internet. And this might also not be allowed on the on-premise environment, where your application should not be communicating with anything outside of the company network. So having those two approaches in comparison, there are always some manual steps left. And this applies especially for the attacks or attack classes that are custom in their nature. But it might still be promising to follow up on especially the probing behavior, as if you go through an attack process, then it usually starts with the attacker trying to learn like a benign user using the application and get an understanding of how the application works. And during this phase, the attacker creates basically some assumptions, and the stage at which he or she tries to verify those assumptions is when an attacker sends out probes to the application. And a key aspect here is that they will most likely not be successful with their first attempt. So they will keep on probing. And this is where we can, as defenders, catch this noise generated by attackers. And as I said, many of the what you could catch with when you're looking for probing behavior could also be done by input validation. And this kind of code is not really complex to implement. So also from the perspective of lines of code. And in general, the detection concept here, the placement of detectors only at those places where you get high fidelity alerts, is also very performant, because benign users are never supposed to come across these detectors in the first place. So basically, only attackers are causing this additional computation, and the kind of computation going on there is not something complex. But still, because of its custom nature, it is very manual when it comes to the implementation. And hence why I am currently looking into ways how we can utilize common practices, like I said, input validation, for example, to also make in parallel use of this concept and other ways of reducing the integration effort. And I think one promising path is to look for application frameworks and how we can make use of them. Because one of the other goals of my research is to enhance this adoption of detection and response capabilities inside web applications. And as applications, and many applications are built on top of frameworks, so we can achieve here a high adoption rate, I think. So some of them also provide reusable components, which make them ideal to scale the detection and response capabilities inside the application. And from a recent study, it turns out that when you put mitigations at the framework level, you have the you are increasing the application's overall security posture the most, because you at the framework level, and especially if it's by default activated, you basically have no chance of avoiding it as a developer. And last but not least, because it is something familiar to developers, we create less friction here if we are making use of frameworks. that was my talk. Thank you very much. And you can contact me on Slack or using this website where I also have uploaded this slide and my paper. Thank you.
That's great. Thanks, Tolga, for the interesting presentation. We have a few questions already who have come through during your talk. Okay. Cyril is asking, did you use DevSecOps methodology to automate your work?
To automate the work?
Yeah.
This is something which I will plan also in looking into. So, for example, what kind of tools and automation scripts are available to make use of, because as I said, I'm trying to reduce the effort, and some application frameworks, for example, deliver these assistant scripts or wizards where you can basically reduce the effort and automate it to some degree. And I want to look into the opportunities that are there, and DevSecOps is also part of it. Yeah, but also because I also want to like reach those people that are not making use of this DevOps practices yet. So this is also why I'm not only focusing on DevOps.
Okay. Another question, always from Cyril, is about the manual approach and the scalability in the enterprise. So he says manual approach won't scale in the enterprise. Do you agree? If so, what do you advise?
Sorry, I didn't understand the first part of the question.
Manual approach will not scale in the enterprise.
Yes.
Do you agree? And if so, what do you advise?
So this is probably because some of the existing approaches are largely manual, or some of the existing projects like OWASP app sensors there is the idea that you as a developer implement those detection points, and which is of course difficult when you don't have these, because they are assuming you have some input validation routines already in your project. And their idea is to make use of this existing input validation routines. But from an automation perspective, this is of course not much scalable. This is why there are solutions like RASP agents, but these are specifically effective or most effective for injection-like attacks. So because of the custom nature of business logic attacks, you won't be able to achieve the same kind of scalability or automation for these type of attacks. And I think these business logic attacks can be equally like riskful to your application or the organization as well.
Okay, then we have another question from Lynsay. I hope that I pronounced the name correctly. The question is, have you got any suggestions regarding a methodology to analyze the attack-related signals from the applications?
The attack-related?
Signals.
I think one approach is to do, because many of those will probably be also have an intersection of what you would do when you're threat modeling your application. But so basically where you are finding out the abuse cases of your application as part of your threat modeling approach. But assuming we don't have, like, for example, this threat modeling process, then any developer having written some code and also the features of their application know which kind of actions should not be legally possible, or basically they should be aware that anything coming from the client can be modified, and things where you as a developer, for example, think, okay, this would never happen, or a benign user would never cause these kind of things coming to my application. These are, I think, the kind of points where you can make use of for this type of approach.
All right, thanks. So another question is from Shreyas, and the question is, how are false positives handled?
How are false positives?
How did you manage false positives?
Because it is up to you. So if we start with the manual approach, it is up to you that you are placing those detectors only there where you get true positives, basically. So you are in control of whether you can, because I also said you can let those detectors look at partial indicators. This is where there is some possibility of getting false positives, but then it depends on what kind of rules or thresholds you use to respond towards this kind of indicators. For the automated approaches, I think those applied on the injection-like attacks, they use techniques like taint tracking and lexical analysis. So these can be very effective for these kind of attacks. And I think this is where, so because most of the solutions are commercial, I am not aware of like the false positive rates, but I would say they would be not as high for this kind of attack classes, as they are basically looking at the root cause of these type of vulnerabilities.
Okay, I think we covered all the questions that have been asked. So thanks again, Tolga, for your very interesting presentation.